Welcome and thank you for joining us today for Challenges and Best Practices for Securing Modern Operational Technology Networks. My name is Raleigh Gould and I'll be moderating today's event. Our featured speakers are Seamus McGillicuddy, Vice President of Research covering Network Management at Enterprise Management Associates, and Tim Roddy, Vice President of Marketing at Open Systems. Seamus has 2 decades of experience in the IT industry as an industry analyst and journalist. His research focuses on all aspects of managing enterprise networks. Tim brings over 25 years of go-to-market strategy, marketing, and partner expertise in cybersecurity, software, cloud, and SaaS, including 15 years of executive and leadership positions at iBoss, Fidelis Cybersecurity, McAfee, and Secure Computing. And before I hand things over to today's featured speakers, I wanted the audience to know that they will be concluding today's presentation by taking your questions. Feel free to log them anytime by using the Q&A functionality. Also, today's event is being recorded and you will receive a follow-up email from EMA with the on-demand playback as well as some additional resources. So I hope you'll check that email out. And now I'd like to go ahead and turn things over to our first featured speaker, Seamus McGillicuddy. Seamus?
Thanks, Raleigh. And thank you, everyone, for joining us today for this webinar about how to secure operational technology convergence with IT. I'm going to speak for a little while about what I'm seeing in the industry as an industry analyst, and I'm going to hand it over to Tim Roddy from Open Systems, and he's going to tell you about what he sees in the industry and what he thinks in terms of how you protect yourself when this sort of thing is happening in your environment. So first of all, operational technology, what is it? It's if you're on this webinar, you probably know it's industrial control systems and manufacturing environments, utilities like water treatment facilities, medical equipment, all kinds of things. Some of the industries that are especially impacted by today are on this slide. You see construction, healthcare, logistics, manufacturing, even retail when it comes to like point of sales and digital signage and things like that, and transportation, vehicles, infrastructure that was usually not a part of the traditional IT environment is converging onto corporate networks, IP networks. Our research at EMA has found that about 83% of IT organizations are seeing operational technology and Internet of Things types of devices and sensors, which are sort of a subset or superset, depending on how you look at it, of the OT thing, are connecting to their enterprise networks right now. And 43% of network infrastructure and operations teams tell us that this convergence is a major driver of their overall network strategy. So it influences how they design, build, and manage and secure their networks. So why is it happening? Fundamental benefits of this stuff. It unlocks data from the edge of your operational technology environment, data that might be isolated in the systems themselves are now suddenly available to for analytics and for business decisions. You can integrate OT solutions in infrastructure with the business systems that people that are typically not directly engaged with OT can analyze. It can help them drive innovation. It can also, you can get more visibility into what your operational technology is doing. It allows you to get smarter and operational technology systems. Sometimes they might have been isolated elements of automation. Think like a robot on a factory floor that may not have been integrated with the supply chain or something, or what's being brought onto the factory floor, the systems that are bringing materials onto the factory floor, for instance. It can also improve customer service and customer support, because if the customer service organization has more detailed information about what's happening with your operational technology, they can be more informed about, when something might be delivered to a customer or resolved for a customer. They'll have deeper visibility into logistics, for instance, or delivery times for a product or availability of a product. It allows for data visioning, like can have more insight into business operations at a high level, like in the executive suite, for instance, and be better informed about, for instance, how well your hospital is doing at getting patients in and out of different lab environments, different medical scanning rooms, and so forth. Like, we're, a lot of our patients are waiting too long to get their X-ray done or whatever. Or I'm noticing that the catheterization equipment that we use is slowing down the processes, things like that. And it can just, drive overall efficiencies, reduce costs. You can even, it can even impact things like sustainability. Like, I'm having better visibility into the efficiency of my OT environment, and I'm looking for ways to reduce the amount of energy that is consumed by my infrastructure. So the opportunities are endless, really. But operational technology security is not ready for IT convergence. Traditionally, a lot of OT organizations, which are typically siloed from IT organizations, their primary security model was reliant upon air gaps. Like our infrastructure is physically isolated from the digital infrastructure of the business, whether that's the internet or just even the local area network that people use for email and for business applications. Like, that is a whole different world. We are air gapping that, so no one can actually get to our OT systems unless they are physically walking into the environment and touching the console that is used to manage the system. Physical access control was the ultimate protection. We can put guys with guns on their hips between the bad actors and those systems. But this drive to converge OT onto IT for purposes like innovation and operational efficiency, things like that, breaks that air gap model. And a lot of OT environments are not ready today to protect, to be opened up to that world of the IT network, the corporate infrastructure. Just anecdotally, looking at a recent cyber signals report from Microsoft, it found that 75% of industrial controllers in Microsoft customers' OT networks have unpatched high severity vulnerabilities. And also, Microsoft found 1 million internet-connected IoT devices running the BOA operating system, which is an open source web server for OT that was discontinued in 2005. So obviously hasn't been patched since then. And obviously is ripe for exploitation. 1 million devices out there, and that's just what's connected. As more systems converge, you'll probably see more of those servers show up somewhere. Also, we see that attacks on OT systems tend to be highly targeted. We've had some high-profile attacks around ransomware on public infrastructure here and there in the last few years. But Nozomi Networks, which is a company that specializes in OT security, they found that, for instance, like water treatment facilities tend to the top intrusion alert they get is a generic network scan, but industrial machinery and in manufacturing environments, they tend to see more alerts about program transfers and weak passwords. And building materials companies that are producing drywall or lumber or concrete or whatever, they tend to see alerts about clear text passwords. And the energy companies see protocol packet injection attacks. So it's malicious actors are pretty sophisticated. They're thinking about individual industries and like what their tendencies are and what their vulnerabilities might be, and attacking that specific target. It's not like they're just doing some sort of horizontal attack, just like throwing something out there looking for opportunity. They're like, I know how water treatment organizations operate. I am attacking them in this way. So what are IT organizations doing to secure OT as it converges onto their IT infrastructure? 55% of network teams tell us they're buying new security solutions like firewalls. 46% say they buy new network access control systems. Specifically, these days, that means something like a zero trust network access solution. And half say they're buying network automation solutions. It's provisioning network connectivity for these systems. It's about implementing network segmentation schema in these networks to like limit what OT systems can reach and who can reach them. And also automating management of firewall policy is obviously a driver there too. You see, this network team manager at a Fortune 100 pharmaceutical company told me recently that his organization has a dedicated team for OT connectivity as it converges onto their IT networks. And he said that they were investing in security to support that. And they're having discussions about how to segment the network to isolate those devices as much as possible. Basically like trying to implement some kind of zero trust strategy around their OT environment as it converges. Specifically, IT organizations are building zero trust controls and policies for operational technology. We asked them, as air gaps become a thing of the past, what kinds of access strategy, network access strategy do you have for OT on your network? You see 12% still tell us, well, we just ban that. That stuff's not touching our network at all. But the rest are like, well, we got to do something. And 23% say, well, we treat it as untrusted. We limit what it accesses. Okay, good luck with that. 28% still trying to create some kind of IoT VLAN, but that's not going to scale very well. Even if you invest in a lot of network automation tools, it's not going to scale very well. 36% are telling us that they're trying to create a tailored access policy for OT devices. Like, I'm going to give this device access to these resources based on its business function, its device type, its security posture, people who have credentials with it, how it's been behaving, things like that. Organizations that tell us that they have a formal zero trust initiative in place are more likely to pursue those tailored policies, which makes perfect sense. I mean, it's basically one of the pillars of zero trust. Create security policies that are as granular as possible. Only 42% of people who enforce these kinds of policies that are tailored to individual OT devices have been completely successful with it. And one of the key things that we found was about the touch points between the network infrastructure and operations team and the cybersecurity and security operations groups. When those groups are not doing well in terms of collaboration, policy implementation is undermined. It's less successful. So EMA, we've been focusing on this the past few years, actually. NetOps and SecOps must partner on OT convergence. NetOps and SecOps is partnering on all kinds of things. To be more honest with you, for instance, secure access service edge, which is a emerging or increasingly mature technology category that combines software-defined WAN with cloud-delivered security and zero trust network access, is driving a lot of convergence between these two groups too. And incidentally, SASE is a category of solutions that can help you a lot with IT-OT convergence. I think Tim will talk about that a little bit more. But we found that 79% of IT organizations are seeing more collaboration between network and security teams because of OT and IoT devices hitting their networks, connecting to their networks. And also, 43% see that network teams and security teams have more influence over overall IoT and OT convergence strategy when they partner together, which happens in other places too, such as multi-cloud, for instance. Cloud strategy. But yeah, when these two groups come together and say, we're going to be on the same page in terms of how we manage this convergence, they tend to come to the OT group and whether in business operations, present a united front and get things done in terms of the best practices that they are identifying, as opposed to being ignored, which often happens for the NetOps team. Doesn't happen as often for the SecOps team, but sometimes if these two groups are not presenting a united front, not on the same page, someone like an OT group might try to work around them, might try to bypass them in some way. Adopt some sort of like shadow IT solution for convergence instead of using a sanctioned convergence onto the corporate network. They might be like, well, I'm just going to start putting ISP modems in my OT edge environments and just connect directly to the internet. You don't want them doing that. On the right, you see the key areas of collaboration that people tell us they are most focused on when they're trying to support OT convergence, from the NetOps and SecOps collaboration, that they're obviously trying to work together on evaluating a technology and procuring what they need in terms of connecting and securing OT systems on their networks, then planning and designing that connectivity and that security, and then actually implementing it. And then not walking away, operational monitoring and logging. Like, okay, I need to get logs off these systems into my SIM, into my fault management, my performance management solutions, so that I can see how these OT systems are impacting me from a network performance perspective and also a security perspective. So it's a whole life cycle and collaboration between these groups to make sure that IT-OT convergence is copacetic. So final thoughts from me before I hand it off to Tim. Obviously, IT and OT convergence is mainstream. 8 out of 10 IT organizations are doing it today to some extent. Network teams must invest in network security, access controls, and automation to protect their network and the systems, these new systems that are coming online. Or I guess they're not new systems, they're old systems that have been air gapped forever, but now they're coming onto your network. And that means that the network team and security team are going to have to partner closely together to ensure that this goes smoothly. Because keep in mind, OT systems are fundamentally insecure and highly targeted. So these two groups need to work closely together to protect those systems and harden them. You may also have to say to yourself, okay, I need to teach these OT groups how to patch their systems, how to replace systems that are no longer supported by a vendor, replace some open source with commercially supported and hardened systems. So think about that as well. And look at everything from a zero. If you have hopefully you have a zero trust strategy in place. If you don't, like, start thinking about things in terms of zero trust. The least privileged access for these systems. Create access policies and segmentation schemes and network security controls that limit exactly what an OT system can do on your network and who can reach it. That's got to be your guiding light. And with that, I'm going to turn it over to Tim. So thanks very much for listening to me.
Thank you, Seamus. Good morning or good afternoon, everybody who's listening to us. I'd like to take a few minutes to dig deeper into a few of Seamus's points. On the last slide, he mentioned a couple that I want to drill down on. First was that OT platforms and systems are fundamentally insecure, and they're highly targeted. So what do we do about it? Is what, he makes the point here. So you got to have an action plan for it. The second challenge here that he noted was that zero trust should drive OT convergence strategy. And everyone's heard about zero trust, but what are the practical things you can do? How do you do that? Well, as Seamus stated, IT and OT convergence is becoming mainstream. But if you're a CISO, CIO, or you're just tasked with securing OT, what are the tactical steps that you should take in order to begin to address the issues and the threats that he just outlined? So let's start that discussion with a quick review of the Purdue model for OT, which is what's up on the slide right now. If you're not familiar with it, the Purdue model is often used as an architecture when designing an industrial control system. The Purdue model employs the principle that this was alluded to by Seamus of segmentation of the ICS network into levels as a very key tactic of securing ICS. And that's fine. But the Purdue model separates IT from OT to increase security. And as Seamus alluded to it, that's beginning to fail. IT devices typically reside at the upper levels, and you see that in levels 4 and 5 on this slide. OT devices reside at those lower levels, 0, 1, 2, and 3. In between, there's what they call a buffer zone. What it is it's an air gap. And so they're relying heavily on the air gap for security. Segmentation for each one of these layers ensures that the devices in each level only interact with each other or with those in the layer directly above them. This way, managing connections does two things. First, firewalls can protect each layer from network attacks, just like you do in IT. And second, the trafficking layers becomes very predictable and simple, which leads to an effective analysis and the ability to do anomaly detection. Are you seeing activity that you're supposed to see? If you're not, then you've got a problem there that you need to look into. When a connection is needed between IT and OT, that buffer zone serves as a proxy or a jump zone. The IT connection ends at level 3.5, where OT picks it up and handles it at the lower levels. This process is performed in reverse when communicating between OT and IT. Next slide, please. Now, Seamus stated that OT platforms and systems are fundamentally insecure, and they're highly targeted. He gave examples of some of the challenges based even on specific types of OT devices. For example, in certain industries, we saw packet injection, we saw weak password problems. He gave a whole slide on those details. But this slide here gives you a little more insight into how true all of this is. The Purdue architecture model relies heavily on segmentation and air gaps for security. But until recently, this was sufficient because IT and OT environments were air gaps, so there were very few concerns. That air gap, however, is disappearing with the advent and use of smart devices in OT itself. And this increased use, you're seeing also of wireless devices being embedded into some of the OT devices themselves. A new piece of machinery will have wireless in it or what have you. And the reason for that is to be able to communicate, to be able to manage it, to be able to do updates. So many OT systems now have components that are directly connected to the internet, and that's a problem. That means they're not going through that air gap in order to get connected to. So recent data will show that, also shows, you see on this slide, that the growth rate of vulnerabilities for OT is actually growing faster in 2021. This is 2022 data which is the last year we have full data, is growing faster than IT vulnerabilities are growing. So the security of the Purdue model, the takeaway from this is that it is broken because you do not want a level 0 device connecting directly to level 4. Next slide, please. So if air gapping OT is no longer feasible because the OT devices need to connect to the internet, then what do you do? Well, first of all, the fact that they have to be accessible makes them vulnerable. So what do we do about that? Well, there's 3 things that we can do and begin to utilize technology such as secure access service edge solutions created by a number of vendors, including us here at Open Systems. There's threefold approach here, the tactical things you can do. One is deploy a dedicated OT firewall within the OT environment. So they're going to be located at different spots within the different layers, depending on your architecture. How many you need depends on how many factories you've got and what have you, where everything's located. Number 2, implement those firewalls properly with segmentation. We've got to segment that OT network. We want to limit how much communication any specific segment can have with another segment. That's a fundamental approach to securing both IT and OT. And finally, as Seamus talked about, implement zero trust network access, ZTNA, not VPN for remote access. It's like if you need someone to check your house while you're away in the winter, you want to make sure that you don't have a plumbing leak. You have to give them a key to the house. Well, that you only want them to check the bathrooms and the sinks in the kitchen. But once you give them a key, they can go anywhere they want in the house. So ZTNA is restricting them just to where they need to be, which is to check the kitchen, for example. Next slide. Let's drill into each of those recommendations. One is to utilize OT firewalls. Once again, we're looking at the Purdue model here, and we've modified it a little bit to show where we would begin to break things down. You want to segment, for example, the level 0 through 3 into a core zone, a monitoring zone, a management zone, and a legacy zone where you might have old file servers and things like that. So first thing you want to do is standardize policies. A global standardized policy is necessary for all OT locations. If you standardize policies, organizations can simplify their systems to reduce the chance of errors and mistakes and improve the security posture. Next thing is to enable threat protection and detection. You need to use your firewall to detect threats with IPS and IDS. Detection and prevention systems detect and help avoid lateral movement in case of a successful takeover of a management device. And again, Seamus talked about some of the different types of attack methodologies that intruders try within OT, things like packet injection, network scans, see if anyone's using a weak password. You want to detect that and act quickly on it by having threat protection and detection in place. Next, you need visibility and control. You need to ensure that all the traffic flow within OT and between OT and IT through that level 3.5 is made visible by the firewalls. Most enterprises are typically surprised by how much OT-IT traffic there is and how IIoT devices have dramatically changed the traffic flow, often because IIoT, by definition, they have to be connected to the internet. A formerly air-gapped environment suddenly depends on the internet, which is the complete opposite of what's intended with an air gap. Second thing you have to do is segment those OT networks. You have to use OT firewalls to segment in the network, and I show 4 of them in the columns at the bottom. Although OT segmentation is not as flexible as that of IT networks, it is effective. For example, a segment can contain a complete OT system solely below level 3. As a best practice, if you segment the OT network into common OT zones, then you're going to be able to better protect it. So typically there are 5 principal OT zones that are in common across most OT environments. They're called core, monitoring, management, legacy, and then the buffer or the air gap. The core zone is central to producing whatever it is that you're producing. They must be isolated and protected so they can run 24/7. You can't have in a manufacturing environment systems potentially being shut down. The monitoring zone is typically where IoT devices live, and they'll monitor, how the device is working, the temperature, whatever it is that you're doing. And then devices in the management zone control the core zone, and they must be isolated. So you want fine-grained control who can get to management, and management zone can then talk to the core zone. If you use zero trust principles on who can get into the management zone, you can really reduce the attack surface because you're going to limit who can connect to the core devices and what devices they can connect to. Next, if you take those legacy systems and segment them in their own zone whenever possible, that's very, very helpful. For example, if you got old Windows NT solutions still, even though that's a very old system, they need to be in their own zone because they're no longer being patched. Yet, however, you're probably going to have somebody accessing them in order to do maintenance and updates of the underlying solution that's running on it. And lastly, that buffer zone, which is often referred to as a DMZ, it's required still to separate the IT and OT zones. And lastly, the third thing you want to do here is replace your VPN for remote access and terminals with ZTNA. Zero Trust Network Access can be used to support the Purdue model. ZTNA enables the remote user to connect to resources such as a set of applications or services instead of the network segment. So you're limiting the user to only the applications they need to get to, not, wow, I'm inside the segment now, I can move around wherever I want. This reduces the OT attack surface and therefore reduces risk. A ZTNA policy enforcement point is deployed at Purdue level 3.5, and it ensures authentication, authorization, and proper handling of all remote sessions. ZTNA also gives you a log so you can have auditing for compliance, and therefore you're only permitting access for certain individuals to certain applications, and you're granting them conditional approval as long as their endpoint's still properly patched and things like that. It's possible to monitor and collaborate during the entire session, and you can record every interaction and access attempt for compliance purposes. ZTNA also typically integrates into an SSO solution. So SSO support for legacy systems is essential. It'll contain a vault for credentials, and it stops the issue of having multiple people, for example, share an administrative account. If production site is subject to certification, ZTNA can often help you fulfill different ISA security standards. And if you meet 27001, 27002 security certifications, it'll help you pass those ISO certifications. Next slide. So how do you do that with a SASE solution? I'd like to talk about how you do it with Open Systems Secure Access solution, which is we refer to as the Open Systems Secure Access Experience. Unlike typical products and outsourced services, Secure Access as a service is designed to eliminate complexity and uncertainty in delivering secure access. Secure Access as a service is more than a solution. It's a very comprehensive and unified approach that provides ease of use and a great experience for the buyer. And in the case of Open Systems, it's backed by 24/7 follow the sun expert operations and support. So you're getting more than just the technology, ZTNA and Secure Web Gateway, for example, but you're getting skilled operators running it on a 24/7 basis. As a result, you get robust security outcomes. It frees you from operational overhead and allows you to focus on your business going forward. The Open Systems Secure Access Experience provides a simple, secure, and cost-effective way to connect your hybrid workforce, your applications, your OT devices, who are all trying to access data to pave the way for you to focus on your core business objectives. Next slide. So in summary, you can indeed address the issues that Seamus and I both laid out about the fact that OT and IT are converging, and therefore the security needs to converge. And you can do it with Secure Access Service Edge. And the three things that you can use Secure Access Service Edge, and in our case, Secure Access Experience, is to, one, deploy a dedicated OT firewall and put them where they need to be in the Purdue model in the right places to segment properly. And segment that OT network so you limit what can talk to what. And then that helps reduce that attack surface. And finally, have fine-grained controls over who can access what applications, what OT devices, and when. And you do that with ZTNA, not with VPN. The VPN gives you a key to the entire house. We just want you to have the keys to the applications or the rooms in that house that you really need to get to. And that allows remote access for OT devices, whether it's your own employees or contractors and the manufacturers themselves of those devices who may need to do updates. As a call to action, if you'd like more information about securing modern OT environments, read our white paper. You see the link there. And you'll be getting as Rayleigh noted, a copy of this presentation and a link to the audio as well for review or sharing with your colleagues. So Raleigh, if you'd like to take over here and moderate the Q&A, Seamus and I'd be happy to answer some questions.
Great, thank you. And as Tim mentioned, I will be providing a link to this paper in the email, so be sure to check that email out. Tim, starting with you, what are common vulnerabilities in OT environments and how can they be mitigated?
Oh, great question. If you think back to the slide I showed, were 2,100 and something ICS OT vulnerabilities in 2022. It's a lot. You think about the different devices that are out there. It's about 10% of what you're seeing in IT, but it's growing faster, so it's catching up. And interestingly, a third roughly had no patch, and 16% had no mitigation. So the biggest impact of the vulnerabilities from all this is a loss of visibility or control, or both. So mitigating them means you really do need to secure them because you're not necessarily going to be able to patch them. And Seamus talked about, the type of things that the intruders are doing depending upon the industry they're in or the type of device. It might be network scanning, it might be packet injection, it might be people using weak passwords so they're easy to compromise. But at the end of the day, you've got to really have improve your visibility and control on access, and that's where the segmentation and the ZTNA comes in.
Thank you, Tim. Seamus, jumping over to you. Security risk is preventing convergence at our company. How do we make the case for it?
First of all, well, if you're a network person or a security person, go across the aisle to the other side and present a united front on this. But there's a huge opportunity here. Like, everyone's talking about AI, right? Like, everyone's talking about enterprise AI and how it can like create new business models and identify opportunities to increase revenue and things like that. You can't do that without data. You can't use something like that to the full extent without data about your business. And where's that data going to come from? It's going to come from operations. I mean, some of it might come from IT operations, but business operations. You need to have visibility into your business. That means breaking down that air gap and making the data that is isolated in these OT systems available to advanced analytics. So if your company is focused on enterprise AI right now, that's how you make the case. Like, you want AI to transform the business, and needs data about the business. But other than that, it depends on the industry. There's so many ways to make the case. Like, better visibility into your supply chain, better visibility into how your manufacturing works, better visibility into the efficiency of how your company consumes energy. It's all about getting access to that data and being able to use that data to make business decisions. And if anyone, and I guess beyond AI, it's also, if anyone is hearing something like a buzzword like digital transformation in your organization, like, that's the other piece. So I think that's, digital transformation is about making business processes more digital, integrated into digital infrastructure, and being able to automate things and make data-driven decisions. That's not going to happen unless you connect OT systems onto your network, so that everything can be integrated, automated, and also data is available to your business intelligence systems, whatever you're using to make decisions about your business. So I think those are some tips on how to make the business case.
All good things to consider. Thank you. Tim, what role does network segmentation play in OT security?
Well, it's a key part of it. We talked a little bit in the presentation. Network segmentation for both IT and OT accomplish the same thing, and that is to, shrink the attack surface. Because when you do that, you're dividing the network into subnetworks, and once you're in a subnetwork, you can't go to another subnetwork. So this results in obstructing lateral movement. Attackers want to get in and then move around, see what's going on. I use the analogy of giving someone a key to your house to check the water in the winter. You don't want them going in and checking out everything in all the bedrooms, right? So that's lateral movement. So if you restrict lateral movement, you make asset isolation easier in the event of an attack, because you found out they got into a segment, they're not going to be in other segments unless they compromise somehow the ability to get into to those as well. So the attacker can't move outside of the current segment they're in, and that limits the amount of damage you've got. So proper segmentation in OT is just like it is in IT. The better job you do with that, the lower risk you're going to have in the event of something going wrong.
Good insights. Thanks, Tim. Seamus, let's take one more question from you. It is, do you have any recommendations for how network and security teams can improve collaboration on OT convergence?
Sure. The first thing you got to do is don't take an ad hoc approach to that partnership, where you just you meet on like a tactical level and talk about things on a tactical level. You have to really formalize how those groups work together, because there's a history of not being able to talk to each other productively. So formalize that collaboration. Maybe even establish some best practices and policies. That might sound painful, but for how these groups work together. I remember talking to somebody at a very large high technology manufacturer who told me that he was a network architect, and he told me that his company had established committees and his peers in global security group, where they talk about priorities for collaboration based on their business objectives, such as IT/OT convergence. Like, okay, this is happening. Let's talk about how we collaborate this quarter on this, so that they stay on the same page. Another thing, pooling budgets. Don't say, oh, you guys pay for that because it's a security thing, or you pay for that because that's connectivity. It's like, no, if we want to make this work, let's pool our budgets on everything that is required to make sure that IT/OT convergence happens properly, securely, safely, and effectively. So as you formalize that collaboration, you also formalize budget sharing. And then also kind of adjacent to the whole formalization of best practices and policies for collaboration, also reorganize groups and middle management if necessary. I often hear from people that when something huge, some kind of huge sweeping change happens, there might be group directors that are protecting their turf and don't necessarily want to support collaboration because it erodes their power and relevance. It seems petty, but it happens. It happens in OT/IT convergence. It happens in cloud. It might happen with WAN transformation and SASE implementations overall. For instance, SASE, which Tim was talking about for a while, that converges network infrastructure and cybersecurity solutions. If you have two directors that want to sort of maintain control over their turf, it's going to create conflicts and turbulence in the implementation of that SASE solution, because it's supposed to be a unified platform for connectivity and security and access control. Those two, the groups that own all those different components traditionally need to be on the same page. And you might have teams or team leadership who are not open to that convergence. So you need to, as a CIO or CISO, you need to be conscious of that. Like you might be in your office sending out a memo saying you two groups work together on this to make sure it goes smoothly. There is a possibility that you might have a director somewhere who sort of doesn't actively sabotage it, but is hostile to the idea and makes things like committee meetings less productive. So just keep that in mind.
Thanks, Seamus. Tim, let's wrap up with you. How can organizations monitor and detect anomalies in their OT networks?
Well, it's just like you do on an IT network, which is you've got to look at put network security devices like a firewall in place, and they typically have IDS and IPS capabilities. That's how you look for anomalous behavior. Therefore, you can detect something going on that shouldn't be going on, and then you can use detection and response tools used by your network security team or your contractor who does that for you, whoever it is, to detect and then figure out how to respond to that intrusion. How you do it depends on what's going on. There's a lot of solutions out there: network detection and response, endpoint detection and response, XDR, which brings them both together. But you need to have the ability to detect in order to do the response, and therefore you've got to have network security devices in place that have IDS and IPS capabilities to look for anomalies themselves.
Excellent. Thank you, Tim and Seamus, for taking those questions. And I wanted to thank our audience for joining us today. As I mentioned, please be on the lookout for that email from EMA with resources from today's event. Thank you again for joining us, and I hope we'll see you at a future EMA research webinar.